In this video, we'll look at some improvements to GPS, and three particular ones of AGPS, DGPS, and RTK GPS. And RTK GPS is essentially a newer version with better algorithms of DGPS. So firstly, AGPS, or Assisted GPS. Now, one of the problems with GPS is, remember, our satellites transmit two things. They transmit the time that that signal was actually sent, but they also transmit something called the almanac. And the almanac contains all the information about where all the GPS satellites are. Now, a cold start, when the GPS receiver has no information, it takes 12.5 minutes to receive that almanac data. So in Assisted GPS, rather than downloading all that almanac data from the satellites, which is actually quite slow, we can actually have that data downloaded off the internet, which can download at megabytes per second, much faster, and we can move from a cold start to a warm start or a hot start much faster. Another way we can do it is if cell phone towers are in known locations, we can use those cell phone towers, each with a different base station that we can identify, to work out approximately where we are, so we can move from a cold start to a warm start, which reduces the time that we need to get our first fix. Another system is known as differential GPS. Now, traditional differential GPS allows us to improve our accuracy down to about 10 centimeters, which is really good considering our accuracy without it, we're talking about 7.8 meters. Here what we have is some ground-based reference stations that are at a known location. Those ground-based reference stations receive the satellite information from the satellites and compare the information they get from the satellites based on what their GPS receiver tells them to the known location that they've been surveyed at, that we actually know that they're at. Based on that, we can compute what the correction is required to correct for the data that's coming from the satellites. And for example, that data might be affected by atmospheric conditions. We can then transmit those corrections to nearby GPS receivers, and those GPS receivers can apply those corrections and get a more accurate GPS determination as a result. There's lots of areas we might use something like this in marine applications, but a more recent one has been in robotic farming applications, where we can have tractors and harvesters that are driven by GPS with high accuracy. Now, I already mentioned that RTK GPS is a form of differential GPS, which is even higher accuracy using newer algorithms than traditional DGPS. Now, this uses those satellite messages coming from the GPS satellites combined with RTCM messages. And those RTCM messages have these correction values that we need to correct for atmospheric conditions, for example. Now, this allows us to have accuracy up to about 10 millimeters, so much more accurate than our DGPS, and much more accurate than our GPS. Now, how do we actually implement RTK GPS? Well, there's a few different ways. One is there's a number of free RTCM services that broadcast information generally over the internet, but they can also broadcast it at 915 megahertz or different frequencies that you can have near your GPS receiver, receive those things and load that data into your GPS as a correction value. There's a number of paid services like Skylark, which cover geographic regions like North America and Australia and different countries. Or you can even set up your own service. And basically, when you're setting up your own RTCM service, you need a base station, and that base station will be at a surveyed point, a location that you know, and you can have that transmitting data either via the internet with some sort of a Skylark style system, or you can send it via like a 915 megahertz transmitter. When you've got your RTK GPS, you can have a receiver, whether it be receiving it over the internet or whether you have a 915 megahertz receiver, to receive that data on something like LoRaWAN or a public broadcast network that you can access data on and freely use. And then you use that, and your RTK GPS will use that correction data to give you your highly accurate GPS values. So we can't just use a RTK GPS receiver by itself as we buy it from the shop. We need to have some way of combining that correction data with our RTK GPS receiver.